So here's problem 8.16. We're told that an aerosol spray can has a volume of 350 milliliters, contains 3.2 grams of propane gas, C3H8 as a propellant, and we're asked to figure out what's the pressure at 20 degrees Celsius. So anytime we know that we're going to plug into a formula, we always want to take the time to clearly identify what our variables are. So P is pressure, and we're solving for pressure. V is our volume, and it has to be in units of liters. So we've got to convert the 350 milliliters to liters by dividing 350 by 1,000. And then the R value, the R values are found on page 263 of the textbook, and each R value has the same unit for volume, liters, amount of chemicals, moles, and temperature, Kelvin. The only thing that varies is the pressure unit, and we're not asked to solve for a specific pressure unit. So I'm just going to choose R equals 0.0821 atmospheres liters per mole K. And then if the key has a different unit, then I can just change my units of atmospheres to whatever unit the key has. All right, and then our temperature has to be in units of Kelvin. So to get Kelvin, we add 273.15 to the temperature in Celsius. And to convert to moles from mass, we're not given moles, we're just given mass, but we can always convert to moles from mass by dividing by the molar mass. So we're not told the molar mass of C3H8, but we are given the chemical formula. And so we can calculate the molar mass, and we divide 3.2 grams by its molar mass, 44.11 gram, to get 0.0725 moles. I just want to say a little aside here about sig figs. Your textbook is very careless about sig figs. Honestly, there's only one sig fig here because the temperature was 20, but I'll probably give my answer. I think the key gives it in just one sig fig. But we don't want to round until the very end, so I'm going to keep at least 3 sig figs in the values that I calculate. I can't for liters because I was only given 2 to begin with, and there would only be zeros at the end. All right, so now let us plug into our equation. So the first thing that I do after I plug into the equation is I always make sure that my units cancel out. And because there are 4 variables in the ideal gas law, there are 4 different ways of rearranging this equation, and they can be found in the slides as well as in the voice lectures. So let's make sure all of our units cancel out. So first, let me just point out the units for R here, atmosphere liters per mole K. And then let's see what we can cancel out. So here are my moles, and my units of moles cancel out with moles for my R value in the denominator. Here is my unit for volume in my value of R, and liters cancels out because volume is in the denominator. And then my units of Kelvin cancel out from my temperature, and then because units of Kelvin are in the denominator of the R units. So everything cancels out except for my pressure unit, and that's what I'm solving for. So when I actually do the math, I get approximately 5 ATM. Let's see, this is a little large. So there you go.